Let's do part C, okay? The mass of the ball. So we get the ball and the spike, and we always do this, right? We let the ball swing down and it hits the spike, you know. The speed of the ball on striking the spike is to show that this is 5.6 meters per second. So what I'm going to do is I'm going to go MGH, and the M is the 3.5 kilograms, even though we don't really need it, right? G is 9.81, H is the 1.6, right? And then that's going to equal 1/2 mv squared. Notice we don't actually need to know the mass of the ball because it's going to cancel out, right? So set this up. You know M, you know G, you know H, you know M. Solve for V. You should get something that's like 5 point. I think I got like 5.5. No, 5.603. So it's almost exactly that, right? Okay. Now, then they say show that the energy dissipated as a result of the collision is about 10 joules, right? Okay, so you're going to compare the original MGH that the ball has, right? Which, by the way, is the same as the kinetic energy it's got when it hits this point, right? Compare that to the kinetic energy of the ball and the spike. Now, notice that the ball and the spike move together. This means that the ball is made of clay or something, right? And it slams into that spike and they just sort of stick together. It's like they stick together. Okay, so what you're going to do is step one, you're going to set up an equation, right? You've got the mass of the ball, velocity of the ball, right? And there's the velocity of the ball. Okay, that's going to equal the mass of the ball plus the mass of the spike. Because when it collides with this spike, momentum will be conserved, right? And that'll be ball and spike, right? The velocity of the BS, right? Okay, so set this up. Step one, momentum is conserved, right? Okay, step two, once you figure this out, you can figure out the energy of the ball and the spike, right? So step two, figure out the energy of the ball and the spike. So 1/2 mass of the ball plus the mass of the spike. The spike is what, 0.8 kilograms, right? The ball is 3.5, right? And then velocity of the ball and the spike. Okay. Now I'm just going to give them a spoiler alert here. I get like between 4 and 5 meters per second for this velocity. Okay, when I do this. Okay, and I use just the 5.6. Okay. And then, squared. So this is 1/2 mv squared. So this is the kinetic energy. I'm using EK as 1/2 mv squared, right? So you're going to get a number here. You're going to go, this will be just, by the way, the mass of the ball. So this is your 3.5 times 9.81 times the height is 1.6, right? So do that and get an answer. Okay. Then step two, find the velocity that this hits, and the ball and the spike are going after the collision, and that'll be, I'm going to say it's between 4 and 5 meters per second, right around 4.5, in fact. Okay, but not exactly. Okay, so calculate that, right? Then take that same value, plug it in here, figure out the kinetic energy of this system, of this, afterwards, right? And then what you're going to do, that'll be some number, okay? And then you're going to go this number minus this number equals, and it'll be about 10 joules. I got like 10.22 when I did it, okay? There you go. Is that 4 marks? I think so, okay?